everyone, myself Shubham Baranwal. Today I'll be explaining you about the controlling of real Firebird 5 through ROS. But first I'll brief you about the working of the system. I hope that you have gone through the navigation video thoroughly. It is very clear that our system as seen from the block diagram fulfills the requirements of ROS navigation packages. Here our embedded controller is Atmega 2560 and all the sensors and actuators are connected to the controller. Since we are not using ROS serial, it is a three-way communication. That is, the controller board communicates with RPi in UART protocol and the RPi communicates with my PC through wireless module. The sensor publishes the distance at which the obstacle is, and the left and right position encoder values are also published through RPi. I'll explain these things in the code more clearly. Then my PC subscribes these values. For the moment it just subscribes encoder values and calculates the odometry of the Firebird 5 as we are concentrating only on the navigation of the board. Let's see the Python script which I'll be running on my RPi. Though I have already commented each and every line, for the better understanding, I'll explain some of the key parts of the code. I have included some of the modules in which import ROSPy from standard messages.message import int64 from geometry underscore message.message import twist import 5pi as pi from sensor underscore messages.message import laser screen are the important ones. Import ROSPy is there for writing the ROS nodes. From standard underscore message.message import int64 is included to publish the encoder value of type int64. From geometry underscore messages.message import twist is very important for the movement of my board. I have included some of the crucial functions in my 5pi file which helps my real Firebird 5 model to perform its basic functions. This file also includes the functions which are necessary for communication between RPi and Firebird 5. From sensor underscore messages.message import laser scan is used for the sensor purposes. I have declared one node called wheel which will subscribe the cmd underscore well topic as well as publish the sensor and encoder values. When my bot subscribes cmd underscore well topic, it goes to the callback function and call sensors and encoder functions. There are three sensors in my Firebird 5 whose specification is described in their respective function. Sharp sensor first function for the first sharp sensor second function for the second one, and sharp sensor third for the third one. In each of these functions I have created a publisher which publishes the distance between the sharp sensor and the obstacle. Each sensor is defined by its angle span, minimum and maximum range. Then I have my another function called wheel which publishes the right and left position encoder values. There are two publishers named left encoder and right encoder which will do the job of publishing. We get these encoder values from shaft left and shaft right functions defined in my 5pi file. There is one file in my PC which will broadcast odom fixed frame and calculate the odometry of the bot using these values. Then as you can see, there are few conditions for the movement of my bot, that is to go forward, backward, turn left and right. I'll explain all this process through a block diagram. While using teleop launch file, I'll be pressing certain keys through my keyboard. This publishes cmd underscore well topic which is subscribed by RPi system. It is responsible for the movement of my bot Further, my RPi communicates with real Firebird 5 and the bot moves. As the bot is moving, the encoder value changes and it is published by RPi and subscribed by my PC, and then my simulated Firebird model moves. This is the process involved during manual navigation of the bot. Now let's control our Firebird 5 and see its simulation in ROS simulator. This is my command to open the ROS simulator with ROS launch file and Firebird 5 model. Then I run my Python file which broadcasts ODOM fixed frame. You can see the Firebird 5 model. In the Py system, I have opened combine.py file which I have explained it earlier. This is my real Firebird 5 model which I'll be controlling it. I'll adjust my window a little bit to get synchronization between the real world and the simulated world. This is my window through which I'll be controlling my real world Firebird 5. First I pressed I to move the bot in forward direction. Then comma for backward movement, J for left movement and L for right movement. You can see the synchronization between the real world and the simulated world. Our model bot is taking the value of the position encoder and is moving accordingly. I will show you this by taking the bot in my hand and moving the wheel. You will see that as I move the wheel of my real Firebird 5, it moves in the simulated world also.
Hope you have understood how my Firebird 5 is simulated and controlled through ROS. Thank you for watching the video.